Assalamualaikum dan selamat sejahtera. My name is Ahmad Hamzah Zib bin Muhammad Nizam. Our team is Muhammad Ikhwan, Amir Hakim and Muhammad Hafiz. Now I will talk about the introduction. Definition is the word widely used in science and engineering field. It can help us to solve our kind of real world problem. Some application of the definition included tangent, normally Newton and method, rate of change, finding a maximum and minimum point to curve sketching. Now I will tell about stationary point. There are three types of stationary point. We have minimum point, maximum point, and we have inflection point. Maximum point, maximum point. If a maximum is located at the top of peak of a peak on the curve. Minimum point if is at the bottom of the throw. Last, inflection. If 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 f prime x is equal to 0, then the point is a stationary point of inflection.
To determine the stationary point is a maximum, a minimum, or a point of inflation, we must apply the second order derivative. First, if d2y per dx2 over than 0, it is a minimum point. Second, if d2y per dx2 less than 0, it is a maximum point. If d2y per dx2 equals 0, it is a point of inflation. Example for the question of stationary point. First question, find the stationary point of y equal x power 2 minus 2 x plus 2. His answer is dy per dx equal 2x minus 2, 0 equal 2x minus 2, 2 equal 2x, 1 equal x, x equal 1. Solve for x, y equal 1 power 2 minus 2, 1 plus 2, y equal 1 minus 2 plus 2, and his stationary point is 1 per 1.
Next, I will tell about rate of change. One of the more important applications of derivative in real problems is to calculate rate of change. Differentiation allows us to find rate of change. For example, it allows us to find the rate of change of area with respect to time. Rate of change for area dA over dt equals dA over dr times dr over dt. How do we find the rate of change? To find the average rate of change, divide the change in y values by the change in x values. Finding the average rate of change is particularly useful for determining change is measurable value like average speed or average velocity.
Okay, next, what is dy over dx in rate of change? If y equals to some function of x, in other words, if y is equal to n expressions containing numbers and x, then the derivative of y with respect to x is written dy over dx, pronounced dy by dx. Okay, for example, a steel tube with border X increased because of long-lasting heating. Border X increased by 3 mm per second. The original length of the border is 12 cm. Determine the rate of change of the surface area for the cube. Okay, for the solution, first of all, we take out all the information from the equation. So we can get x equals to 12 cm and dx over dt equals to 3 millimeter per second. And then we convert millimeter per second to centimeter per second. After that, we can get 0.3 centimeter per second. Surface area is A. Surface area equals to 6 times x times x. A equals to 6x squared. So dA over dx is 12x. After we got all the answer, we can put all of the answer in the formula. The formula is dA over dt equals to dA over dx times dx over dt. dA over dx is 12x, so x we replace with the 12 centimeter, and dx over dt is 0.3. So we got 43.2 centimeter square per second.